Yesterday we started this topic, the periodic table, the regular arrangement of the elements on the basis of the proton number. The vertical columns are known as the groups, which represent the number of electron in the outermost shell, and the horizontal rows are refers to the period, shows how many electron shells are there or how many shells are occupied by electrons. And a periodic table consists of metal, non-metal, and metalloid. So this is around this staircase line, you will find metalloids, and on the right hand side you have non-metals, on the left hand side you have metals. As we move across the period from left to right, the element become more non-metallic. So on the left hand side there are more metals, on the right hand side there are non-metals. And as we go down the group, so what happened? It because become more metallic or tend to lose electron easily. So metals, non-metals, and metalloid, this we discussed yesterday, and we discussed some properties of group 1 alkali metals. Now, as we know, the periodic table is divided into different groups, and elements in each group have certain properties. Alkali metals we discussed yesterday. So how we can identify an alkali metal, like which alkali metal is there? The alkali metals include, you have lithium, sodium, potassium, rubidium, cesium, and francium. So how you can identify these elements? There's also a simple test, which is also known as the flame test. So using a flame test, we can identify these elements. You don't have to learn the flame colors for each element in this group. Only the first three elements, which is lithium, sodium, and potassium. So how we carry out a flame test? So what we will do, like example, say this is a sample. So this is a sample. You don't know which element is this. You know it's an alkali metal, but you don't know which element is there. Maybe lithium is there, sodium is there, or potassium is there. So what you will do, if you want to identify the element present, you will take a nichrome wire. What is this nichrome wire? Nichrome wire is actually an alloy which is a combination of nickel and chromium. That's why we call nichrome. Ni is from nickel and chromium, from chromium it's chrome. So it's called nichrome wire, which is an alloy. Alloy means a mixture of the metal. So what we will do, so we'll take a nichrome wire, then we dip this nichrome wire in concentrated HCl. Like we'll convert this nichrome wire is an alloy and it does not react with hydrochloric acid even if it is a concentrated. So we take a concentrated HCl and we dip this nichrome wire in concentrated HCl. Then we will take this sample. So first we have a nichrome wire, then we dip the nichrome wire in concentrated HCl, and then third we will take the sample. So how we'll take the sample? Just take the sample which we want to identify and then place above the flame. For example, you have a Bunsen burner or a burner is there. So you place this nichrome wire, which is having a sample above the flame color will change. As the flame color will change, you can recognize from a specific flame color that which alkali metal is there. It can be lithium, so it will be scarlet or red in color. It can be sodium, so you will have yellow color, or it can be potassium. So it can be sodium, which is yellow in color. It can be potassium, lilac, or violet in color. You don't have, these are more extra elements are written here, but you have to learn for group one. Sodium is there, which will give golden or yellow in color. Potassium is there. It will give violet or lilac. If there was lithium, then red is acceptable. Crimson red or scarlet red or red is, only red is also acceptable. So how we carry out a flame test? So we'll take a sample. So how we can carry out a flame test? You can see this is a Bunsen burner. Why the surrounding is dark? So that the color is easy to observe. So first we'll take a nichrome wire. Example, this is a nichrome wire. We dip this nichrome wire in HCl, concentrated HCl. And we will take the sample which we want to recognize or identify, and place the sample, the nichrome wire which is having a sample, above the red, the hottest part of the flame. Hottest part of a flame is when it's blue in color, that's hot part. So we'll place it and observe the color. So you will see different colors when we'll take different samples. The example in this one, the colors are due to lithium, sodium, potassium, calcium, strontium, barium, and copper. But your course outline, you should learn for sodium, lithium, sodium, potassium, and copper, the colors. So the Bunsen burner, which is releasing the energy, and it appears to be blue in color. We did not place a nichrome wire till now. It's normal flame is there for a burner. So if we dip nichrome wire in HCl, and as we place, so you can see here, the nichrome wire may not be visible to you, but you can see this part, the flame color turned or changed. Why it is changed? Because as the samples start to burn, which element is there, that element is responsible for a specific flame color. The first element here is lithium. So you will see crimson red, or you can also say red. The second element, this is about the burning of lithium compound using a nichrome wire. Nichrome wire is, why nichrome wire is used specifically? Because nichrome wire are, why we put, what's the reason why we put HCl? Why directly we did not burn? Why, like example, I should take a lithium and I should place above the flame and then I should burn. It will give me the red or crimson red color. Why I convert into lithium chloride? Because when I dip in HCl and take a sample, it will turn into lithium chloride. Because group 1 alkali metals, they are highly reactive, so they can react with the surrounding easily. So maybe before place, and it will be explosive reaction. So their compounds reactions are very slow as compared to the metals. That's why we first dip the nichrome wire in HCl and convert into chloride salts, not directly place above the flame. So we are burning the compound, not the element directly. That's, there is one reason, that's safety as well. And the second reason, the chloride compounds are easy to vaporize when burned. That's the second reason.
Sir,
Yes.
if we burnt the metal, only the metal, not the compound, there would be an explosion
Yeah,
or
it can
anything
be,
to see.
because for alkali metal it can be explosion. So that's why for a safety reason we use a chloride salt. So now you can see this is the second part. You can see the flame color when we take a nichrome wire burning, the flame color changes. So why this yellow color is there? That's because of sodium. Is it clear, Afif? So
Yes, sir. Thank you.
we take concentrated HCl, dip in nichrome wire, dipped in concentrated HCl, take the sample and burn, so that the sample will be a chloride salt. Chloride salts are easy to vaporize as compared to other salts. Directly metal is not burned. We are taking a compound of that metal and burning that compound. So you can see as we are burning the flame color, there's a different flame color which shows that the element present was sodium. This is still sodium, but if you take a greater amount of the sample, then greater intensity of the flame you will see. So the third one, you can see a purple color flame is there. So why this purple color flame is there? That's because of potassium, which is lilac in color. So you have to learn four element, the flame colors. You have to learn about lithium, which is scarlet red. You can mention for the sodium, which is yellow in color, and potassium, it is purple in color. Why we use nichrome wire? What is the reason? Because there are two reasons. Number one, nichrome wire inert in nature. Inert in nature because it's a combination of two elements, nickel and chromium. And when you compare the reactivity of nickel and chromium, they are least reactive elements. So when we dip this nichrome wire in HCl, concentrated HCl, that nichrome wire will not react with concentrated HCl. That's one reason. The second is because it's an alloy, so it is having a higher melting point as compared to that of the pure metals. So it will not melt when we place above the flame. So these are the two reasons. One is inert nature of the nichrome, and the second is high melting point, so does not melt above the flame. This is about the calcium, crimson red in color. Here, this is calcium. So different elements giving a different color. I will move on to the copper one. When you place a copper, because you have to learn only these four elements: lithium, sodium, potassium, and copper. So this is when you place a sample which is having a copper compound, copper chloride. So what you will observe, it is acceptable that you mention a green, or it's also acceptable if you mention blue. Is it clear? This is how a flame test is carried out. Any doubt in this part? Then group 7 are also known as halogens. The group 7, which include the elements which are there in group 7, you have fluorine, chlorine, bromine, iodine, and astatine. This is known as a group 7. Group 7 are also known as halogens, halogen family or halogens. What is the reason why we call them as halogen? Because the term halogen means salt former. So when they react with metal, they always form a salt. That's why we call them as halogens. Like sodium react with fluorine, sodium fluoride, which is a salt. Potassium react with chlorine, potassium chloride, which is also a salt. So bromine reacted with example calcium, calcium bromide, so it is also a salt. And silver react with iodine, gives silver iodide, that's also a salt. So these elements, they form salt. That's why we call them as halogen, this group 7. As they are in group 7, how many electrons will be there in the last shell? Because the group number shows the number of electron in the last shell. So group 7, they will have 7 electrons in the outermost shell or the last shell. But when you compare the size as we go down the group, as you can see, fluorine atomic number is 9. So when we draw the structure of the fluorine, this is a nucleus. The first shell, it will have 2 electrons, and the second shell, it will have 7 electrons. When we move from fluorine to chlorine, chlorine is 17, atomic number 17. So it means 17 electrons are there in a chlorine atom. This is a nucleus. So first shell, it will have 2 electrons. Second shell, it will have 8 electrons. And the third shell, it will have 7 electrons. So if 7 electrons are there in the last shell, and these are non-metal, how the non-metal tend to react? Non-metal tend to react by gaining electron, taking electron. Which one you think can gain electron easily? Fluorine or chlorine? Which one can take or gain electron easily? Fluorine can take electron easily. Why? Because fluorine is smaller in size, so greater attraction. Fluorine is smaller in size, so greater attraction to the electron. So that's why it can gain electron easily. So if non-metal can, because non-metal react by gaining electron, so if fluorine can gain electron easily, what it shows? It shows fluorine is more reactive than chlorine, because non-metal tend to gain electron. So when we compare the size, like this is fluorine, this is fluorine, then we have chlorine. And these are non-metals, so these non-metal tend to gain electron. So which one? As you can see, fluorine is smaller in size, so it can take or gain electron easily as compared to chlorine. And further, as we go down the group, the size is increasing. So bromine is much smaller in larger in size as compared to that of chlorine. So this bromine can gain electron. It need, like, compared to chlorine, chlorine can gain electron easily as compared to bromine because larger in size. So the attraction by the nucleus to the electron, because nucleus is attracting the electron, so nucleus cannot attract electron easily as there's a greater or larger in size. That's why chlorine is more reactive than bromine. So as we go down the group, so as we go down, what we'll observe about the reactivity? So down the group, what we observe about the reactivity? We observe the reactivity decreases as we go down the group. So it is opposite to group 1. For group 1 metal, the reactivity was increasing, but for group 7, the reactivity is decreasing. When we compare the states, fluorine is gas, and you have to learn the color. Chlorine is also a gas, bromine is a liquid, iodine is solid, astatine is also solid. These are the state of these compounds, these elements at room temperature. Color of a fluorine, what is the appearance or a color of a fluorine? Fluorine is pale yellow, light yellow. Chlorine is yellowish green. Bromine is red brown. Iodine is purple or black. acceptable black. It is purple. About the acetine also black in color. So you have to learn these colors as well.